Good morning, everyone. My name is Timothy Lee Grant, and today we are going to be talking about k-nearest neighbors. So this is probably one of the most simple machine learning algorithms that really demonstrates what is happening with machine learning and the basic idea behind machine learning. And then later on, we'll get into more complicated models where it's much more math intensive. But this one gives you kind of a good understanding of what machine learning is and what it's capable of and what are the type of questions that machine learning even tries to answer. Okay, so the first thing that we're going to talk about is what k-nearest neighbors is. It is a classifier, okay? So the purpose of this algorithm is to take in input and then it's going to learn from that input. Then when you give it a new point, it is going to classify this point as being in one of however many groups there are. So your input data is going to have different attributes. It's going to have different characteristics. Then it's also going to have what's called a label, and that's what we're trying to predict. And in a classification algorithm, the label is going to be a class or a group. Okay, so in the example that I'm going to show, there's going to be two categories, and categories are distinct. All right, so a category could be something like car, or if you want to break car down, you can have many categories within cars. So for example, Kia, Lamborghini, Ferrari, Mitsubishi, or whatever they're called, right? So you can have multiple different car types. It's a distinct, meaning you can't be half Ferrari and half Kia. That doesn't make sense. You are either Kia or Ferrari or one of the other, right? It is a group. So the point of this algorithm is to take in, it's going to have different characteristics. Maybe if you're doing something with cars, it's going to have different attributes such as top speed and size, miles per gallon, right? All of these are going to be attributes of the car. And so you're going to feed that in and say, I have this new car. I know the attributes. I know it's top speed. I know it's miles per gallon. I want this algorithm to tell me what class it belongs to. Does it belong to a Ferrari is my point, because I don't know what my point is. I want to be able to tell, is it a Ferrari or a Lamborghini or a Kia? Okay, so that's what this algorithm does. It takes in a training data, and that training data has the actual classification which belongs to it. Okay, we're going to get to that. Then what you do is you have a new point and you say, okay, with this new point, I want to be able to determine what class it belongs to. All right, so now let's get into the example which I created. So in this example, we have two classes. We have monkey and insect. So these are two different classes. Now, these classes have two different attributes. So we measured two different attributes, and this is the training data. So what that is we went out and we looked and we got a whole bunch of data. All right, this is how we learn. This is how the algorithm learns. It has to have training data. And so we found one monkey, and his size was 25, maybe kilograms or something like that, right? 25 kilograms. And then we measured the IQ, and this monkey had an IQ of 82. Well, this insect over here had a size of 3 and an IQ of 11. Okay, so each of these are individual instances which we found and we recorded, and now we're going to put it into our algorithm. And notice, we have both the size, the IQ, and the label. We know if it's a monkey or an insect, and we have to know because this is training. This isn't predicting yet. We're on the point that we're predicting, we don't know if it's an insect or a monkey, and that's our output. The algorithm is going to output the prediction. It's going to take in these two attributes, size and IQ. It's going to take that in of our unknown point and output a category. It's going to say this is an insect or this is a monkey. Okay, so k nearest neighbors will take in attributes of an unknown point and output the class which it belongs to. Okay, so here's our two attributes. We only have two in this example. We can have more. We'll get into that as well. And then here's our label. So I drew it here. Here are a bunch of insects. And you can see, all I did was I took these two inputs, size and IQ. Okay, I just took them, and each of them I graphed onto the actual graph, right? So here we can see a cluster, and here we can see a cluster, right? So took that and just put it there. Okay, so now if I give you an unknown point, okay, and we know it with the unknown point, you know the different inputs, okay? So I'm going to tell you that for this unknown point, I don't know what it is, but it has a size of 26 and an IQ of 82. So it's right here. What do you think this star is? Do you think that's an insect? No, I don't think you do, right? Because your brain intuitively said, well, hold on, this point right here, even though I don't know what the class it belongs to, because its attributes are very close to the other points that are monkeys, I think that's probably a monkey. If we had another point and it had a size of 5 and an IQ of 15, and maybe it was right there, you'd say, well, even though I don't know what the classification is, I don't know what class it belongs to, because it is closer to points that are insect, I think I have a very strong suspicion that this point here is also an insect. And that is exactly what k-nearest neighbors classification does. What it does is you are given a point, and the algorithm runs through all of your training data, okay? And it finds the k nearest points. Now, k is a parameter which you get to choose, okay? So k could be 1, k could be 2, k could be 3, k could be whatever you choose. But let's just say k equals 1 in this case. What that means is it is going to take in this point right here. It knows the two attributes. It knows the size and it knows the IQ, but it doesn't know the label. It doesn't know the classification. That's what we're trying to predict. So it comes here and puts it there, and then it says, okay, so I know the inputs. I'm going to search through all of my data points, and I'm going to find the nearest neighbor. Okay, so it measures here to here. It says, okay, the distance is maybe 25. Then here to here, it says 22 maybe. That one's a little bit closer. Then it comes here and it says 4, right? It's only 4 away. Oh, so far this is the closest. Then it comes here and maybe this one's 30 away. It says, okay, well this one's still closest. Maybe then this one is 2 away. And this one is 3 away. And it says, okay, well this is my closest one. Here's my closest point, and this is the training data, right? So it looks through the training data. It finds the closest point, and then looks at the label, because in the training data, you know the label, right? I see an M right there. I know that this is a monkey. So then what it does is it says, okay, this point right here, I was not given the classification, but the closest neighbor is monkey, and therefore I am going to say that this is a monkey. It's going to output monkey as the classification. All right, so now I mentioned that K does not necessarily have to be 1. When we looked at K equals 1, we found the closest neighbor and said, that's it. If the closest neighbor is a monkey, then we have a monkey, okay? But you don't have to choose the closest. You could choose the 2 closest. And then in that case, you would say, okay, well, here's a monkey and here's a monkey. Well, found here at this point in the training data, I don't know which one it is, but look, maybe this one is the closest. It looked at these attributes and calculated the distance and said that this is the closest and then this is the second closest. It looked at the label, said, oh, they're both monkey, and therefore I'm going to classify this point as monkey. Or you could have 3. Oh, finds that one, okay? Or you could have 4. Well then, all of a sudden, you have 3 monkeys, and 1 insect. So what do you do in this case? Well, you just have to average, like, okay, which one is, or not average, but it is argmax, which means you find the maximum classification, like which classification is most well represented. If you have 3 monkeys and 1 insect, you find the classification that has the most. Makes intuitive sense. So then you say, okay, well, there's three monkeys right there. Therefore, I'm going to predict, I'm predicting a classification. I predict monkey for this point, this unknown point. That's the idea behind K nearest neighbors. So, we have 2 inputs right here. And it outputs insect or monkey. So there's 2 classifications which it can output. But we can actually have a third one, right? Let's do dog. So dog. And now what we're going to do is this is our training data. We're going to go and just measure some dogs. So let's say this dog had an IQ of 50. And this dog had an IQ of 55. And it had a size, this dog that had an IQ of 50, we measured its size to be 15. And we measured this dog's size to be 20. Okay? So 15 for the size input, 15, and then 50 right here is dog, and then the other one, 20 for size, is right here, and 55 is going to be here. All right, so now if we have a point right here, and we're trying to say, all right, here's our point. Is it a monkey or a dog? Well, now it's a little bit more difficult to tell, right? Well, all you do is you choose a K, you say K equals 1, and so then in this point, you look at all of the training data, and you find the distance between here and here, 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 okay? Then all of that is going to evaluate to a number. You find the number 1, the closest point. Let's say it's this one. This is the closest point. And then you know the point. Then you find the label and say, the label is a dog. Therefore, my output I'm going to classify as a dog. Okay? Dog. Then maybe if you say k equals 3, it's going to come here. It's going to find this is the closest point. This is the closest or second closest point. This is the third. Well, now we have 2 monkeys and 1 dog. So it's going to find the argmax. It's going to find which classification has the most. Well, there's 2 monkeys here, so I'm going to output and say that this is a monkey. All right, so that's essentially how it does. And so this has 3 classifications, and I want to point out that this is still 3-dimensional. Okay, let's look at the dimensionality of this. Okay, what are the dimensionalities? Here's 1 dimension. We have size. Okay, this is 1 dimension. This is 1 input. What is the other input? IQ. Okay, so this is a 2nd dimension here. So we have 1 dimension, 2 dimensions, and then we have 1 output, which is the classification. And it can only be 1 class, right? Here's 1 class is an insect. That's 1 class. Dog is another class. Monkey is another class. So each point has 1 input, 2 inputs, and 1 output. 3. This is a 3-dimensional situation that we have going on here. Okay? Even if we had more classifications, let's say goat. We have a goat, and it's here, and here, and here, and this is our training data, right? So we just measured goats, and we found their size and IQ to be right here, and right there, and right there. These are individual goats that we measured. We found it. Well, how many dimensions? Okay, each point has 1 input, has 2 inputs, and then 1 output. So 1 input, 2 inputs, 3. It's still 3-dimensional. But can we make it 4-dimensional? Oh, yes, we can. What if we had an axis coming out here that was IQ, size, and I'm trying to think of another attribute which would make sense for an animal. Max speed, maybe? Like how fast they can run? And it had speed come out here. All right, so now an insect is going to have we're going to go out, measure the insect. Say, okay, well, this insect has a size of this, an IQ of this, and a speed of this, right? It's going to have 1 input, 2 input, 3 inputs, and then output, it's going to have a class, which is insect. So it has 4 dimensions. Does that make sense? 3 input, size, IQ, and max speed, and then 1 output, which is its class. And each of these points is going to have the same, right? The goat has a specific size, a specific IQ, and a specific max speed. So all of these inputs are going to have each individual training data point is going to have 3 inputs and 1 output. And then when we have a point which we want to classify, we are going to be given 3 inputs. We are going to be given the size, the IQ, and then the max speed. And we're not going to be given the label yet, right? That's what we need to predict. So then the algorithm is going to use the distance formula, and it's going to calculate the distance between our point and every single instance in our training data. It's going to find the closest point. Maybe it says, all right, well, it's this is number 1, this is number 2, and this one is number 3. And then we're going to, well, it'll rank all of them. So here we go. Number 4, number 5, 6, 7. So it ranks all of them. And then it looks at K. Says, all right, well, K is 2. So I need to find the number 1 and the number 2. And actually shows why you wouldn't use 2 as k. So watch this. Number 1, we look at the label. Here's the specific point, and it says, okay, well, this is of class insect. Now I'm going to look at the second nearest point. This is the second closest point. So the smallest distance. This has the smallest distance. This has the second smallest distance. It's of class monkey. I have 1 insect and 1 monkey. What do I return? See, this is why you don't do k equals 2. You want k to be an odd number. So in that case, k would be 3, right? So we would go 1, 2, and 3. So k equals 3. So we have 1 insect, 2 insects, and 1 monkey. Well, the most recurrent classification is going to be insect, and therefore we're going to predict insect. Okay? All right, so that is the basic idea behind k nearest neighbors. You are given inputs in your training data, and you find the closest neighbor to your input, and you find its label and classify it as such. You just copy the label, which is of the closest point, and predict that. So you say this unknown point, I don't know what the classification is, but I know that its closest point is a monkey, and therefore I'm going to predict a monkey. But how do you actually go about finding that distance? Well, the most common way of calculating distance is Euclidean distance, which is given by this equation right here, okay? So you might have noticed this equation might seem more familiar if I go like this. x1 squared plus x2 squared. All right, so right here, this is the distance between a point and the origin. Let's say we're interested in this point right here. So what we're going to do is this point has two inputs, size and IQ, right? So it has here a specific x1 value. In this case, we're going to say size is the x1. Right now, it looks like that's about 3. And then but this is between the origin, this point and the origin. So the origin has x1 of 0. So minus 0 squared plus, then this point has 79. 79 minus 0, because the origin has an IQ of 0 right there, and squared, and then take the square root. So that's how this, if y2, if your second point is 0, 0, it simplifies down to this. And this is the equation that a lot of people have seen. Like, you take the first component, square it, you take the second component, square it, and then if you have a third component, if this is 3D, if there's another component coming out here, you would take the third component and square it and add it up and then do a square root. But if you're not interested in the distance between the point and the origin, but rather between a point and another point, you have to take the components of the 2 points and subtract them, okay? So x1 is going to have, let's see, x1 and y1. So they're going to have one component, which in this case is size. So this one is size, and then the x, or the 2 right here is IQ. So now we subtract between the 2 points, x1 minus y1. Okay, so that is going to be, let's say that we're doing between these 2 points right here. So I want to know the distance in the x1 component. X1 is along this way, so from here to here. Does that make sense, right? Here is the x1 component of one of the points. This one is x1, right? X or y, right? So here is the first component between the 2 points. That's going to be some number, right? Let's say 3. I don't know what it's going to be, but it's going to be some number. Then, now I want to find this component, the second component, right there. So that's going to be between here and here. Okay? So this is good. I said this is 3, and this one, it looks a little bit bigger. Maybe that one's 5. So 5. So then 3 squared, 9, and 5 squared, 25. So 9 plus 25, and then square root that. This is going to come out to be some number. And that's what we say the distance is between these 2 points. Does that make sense? So here's one component. This is the size component. This is the IQ component. Okay? And then there's no reason why we can't have a third component, right? Let's say x3 and y3. So now the x point has a certain number, which is in the third component. And it's going to be something, right? It's just going to evaluate to a number. And then the y point, the star, is also going to have a third component. This is a 3 right there. And so then the equation is going to be plus x3 minus y3 squared, like that. So then this is just going to evaluate to a number again. So for 2 points, you have 1 point, 2 point. No matter how many dimensions, this can have a fourth component, a fifth component, a sixth, seventh, eighth, ninth, 10th. For however many components, you have 2 points. For a distance, you're always finding 2 points. Either with this one, I said, well, here's 1 point, but the second point was hidden. It was the 0, 0. So this is 1 point, this is 2 points. We're always in distance. You can't just say, oh, what's the distance between 3 points? That doesn't really make sense, right? If I'm here and the eraser's here and then my pen is here, what's the distance between us 3? That doesn't really make sense. It would be like, I would have to be 1 point and this would be a second point, and that kind of makes sense, right? So for distance, you only have 2 points, but you can have as many components in that, right? Because here's one component, size, here's the second component, IQ, and then something else, you would have 3. So it makes sense for me to look on a two-dimensional plane, right? And say, okay, well, my nose and this eraser, right? Well, this makes sense, right? It's on a 2D plane. But then if it goes into 3D, we can still talk about distance, right? Well, okay, it would be this component, plus this component. And then if I go out this way, it would be plus this component, right? So it would be this component, and that component. There's 3 components to it, but there's only 2 points. Does that make sense? So that's the basic idea behind k-nearest neighbors, is you have an input, 1 input, 2 input, 3 inputs. It can abstract to however many inputs you want, and you're going to get that in your training data, right? So if we got another input, which was max speed, I would have another column right here, which said max speed, and each of these training data points would have a max speed, okay? So we get the input, then we have a new point right there. We don't know the classification yet, but we want to figure that out. So how do we figure it out? We go through every single point in our data set. We look at it and say, All right, I am going to find the lowest distance, and then I'm going to see the first, second, third, fourth, and I'm going to rank them, okay? Then I take the k, however many, let's say that it's k equals 3, so I'm going to find the first, second, and third closest points. I'm going to look at their label because I know it, it's in the training data. I'm going to look at their label. I'm going to take the classification, which is the most occurring, and then predict that. Okay? That's the basic idea behind K nearest neighbors. So I hope that I kind of made this a little bit more clear. If you have any more questions, please, please, please let me know. Give me a comment, and I would love to either be able to change my videos, make them more clear, or possibly explain something more. So if you guys could leave a comment letting me know what you thought, I would greatly appreciate that. I hope you guys have a wonderful day, and thank you so much for watching. All right.